Hello everyone. I'm going to explain how to use R to do regression analysis of methane yield data. And this also can be done in Excel, but just as this is just example of how to use R to do that. So what is regression? As you all know, that it's statistical methods to model a relationship between two variables, basically one dependent and another one or maybe more of independent variables that they call it predictors sometimes. And there are two types of regression, maybe linear or simple regression, which is actually a relationship between two variables, basically, or a single independent variable and dependent variable, or multiple linear regression, which involve uh, one output or one dependent variable and more than one independent variables or predictors, basically. So if we have this experiment actually has been done to study the effect of retention time in days and the methane yield, how to do this in R. So the first thing actually to do this, we have to prepare the data. Because this is actually very simple example, we can just put them in the prompt. Using this data and the data frame, we can define the first actually dependent variable, which is the retention time, and the dependent variables is methane yield, and the independent variable is the time or the retention time. Here, this is the yield data, and this is just 5 data points. It's easy to do it in the prompt. We don't have to do it in Excel or other inputs, basically as a file. If you have many data points, we can just use Excel and put it as CSV format or other format that can be read by R. The thing actually now we have to fit the second or actually the um, second step, basically, or the most important step is to fit the model, linear model. We can have actually this is the code here for this one. The model is LM, and then this is the dependent variable, which is methane, and the independent variable. We have only one uh, dependent variable, which is retention time, and of course we have one dependent variable, which is the methane yield. And here, this is the data. We can define the data here to be also the input for this model here, and for this kind of relationship here. This is just one linear and simple regression model. Here we can summarize the model output. We can see what comes out from this models, and then we can actually plot also the data. And plotting the data means that we have to see actually the measurements against the model. And here, this is also the data. We can read the data from the data input. Here we have to have the retention time as X, and this is Y, or basically the vertical uh, axis. This is the dependent variables, and on the X-axis is uh, predictors or the dependent variables. So we can also define the label of different axes, and we can also define the color if we need to. We can also put the fit model or the line actually that is the perfect actually, which is basically the predicted values using the line in this case. So we can see actually this in R here. This is just, again, this is basically the code that you can write in the R as a file, and then you can run the model and you can get this kind of outputs here. And here, this is the plot that we can just read from this, or they can be resulted from this code. I would like to just stress here, this is basically the coefficient here. We can see the y-intercept, which is -8. Y-intercept means that what would be the yield if the time is 0. Of course, this is maybe not logic, but this is basically a fitting parameter that can actually help to make this kind of line or predicted values to be closer to the measurements. And here, this is basically the slope. Sometimes actually they call also this kind of retention time. This is basically the slope. Again, I forgot actually to mention that if you can also in the code, you can say the intercept will be the coefficient model 1, which will be the first value come from this model is from this summary will be the or from model actually will be the intercept, and this you can also write this one as a slope for extracting the slope from the model, and this is will be uh, 2. Again, this is just the determined values, and here you can see that the retention time, of course, has t, or this kind of p-value is less than 0.05, which means that this actually the retention time has a significant effect on the methane yield. Also here you can read also here this is the residual standard error, or the most important actually to look at the multiple r square and also adjusted r square. So basically you can see the values for determination factor, sorry, this determination coefficient, which is the first one, which is multiple r squared, 0.97, and the adjusted one is uh, is a little bit less, because basically the adjusted value basically it's a matter of relationship between the predictor, how many input to the model or dependent variables, and the more actually dependent variables you have, the more actually R value compared with adjusted value. Probably we'll get to this one sometimes actually to explain this in detail. With that, I would like to thank you and hope this is useful for you. See you next time.